Hey guys, Lenny Reed, Dynamite Diesel Products. Adrian has been on this AFM for 2 years now, and he's hands down the best at it. He's wrote all the programs in this. It was a struggle. When we were given this machine, you know, you get told that it's going to be awesome right out of the gate, but then there's a big learning curve every time you bring in a new technology. Going from this extrude hone stuff, extrude hone media is kind of like a silly putty, like a clay, and we had this designed in different grits, so it would cut differently in different size hole diameters. So with this stuff being one option, and then AFM being another option, AFM, as you can see, is a liquid, and it's got its cutting agent suspended into that liquid. So two totally different technologies. They both sort of kind of do the same thing, but not really at all. With extrude hone around here, we've now got the AFM machine dialed in, so we're doing pretty much up to about 15 thousandths of an inch with AFM, and 15 thousandths and greater than, we're using extrude hone still. Now, a lot of people have kind of bagged on us for using these like little Gilmont AccuCals for 20 years now, but they're super repeatable, they're super accurate, and basically, if I take any of the OEM nozzles and I put them on that AccuCal, I can see a 2 or 3 liter per minute variation. And truthfully, honestly, that's like a 10% variation. How do I know that's correct? Because we then take the nozzle, we put it in the hydraulic test stands, we try and calibrate them, and they're just a pain in the ass to calibrate. So if we balance them with AFM or extrude hone and use this as our truth meter, then everything down the line gets calibrated very, very quickly, very, very easily, and the shims are always like very relatable. You can understand why they're doing what they're doing. So I 100% do believe in this thing. Everybody that has these is using different regulated air pressure. So this is kind of like a dynamometer. You're gonna go from one dynamometer to the next dynamometer, and they're not gonna give you the exact same number, but at least you kind of have a general idea. 500 to 550, 500 to 525. AccuCal is kind of the same thing. With that being said, this thing has a flow meter built into it as well. And when we were showed how to use this thing originally, it was based on like a very, very large, fast production rate type of deal. So pressure was cranked up, we were cutting really quickly, but a lot like rail pressure, you're gonna see that as I start to process parts, we're gonna start making media pressure. And if we try to crank it in there really violent, really quick, the flow meter didn't have enough time to actually catch up and know where it really was. So we were seeing the same 2 or 3 liter per minute variation on that as well. So we just had to change media. We've got, I'm gonna guess this is the 6th or 8th different style of media that we've ran in here. And we've edited recipes, edited recipes, edited recipes. So honestly, like, there's guys in the shop that are kind of 2 or 3 star at this machine. I would say Adrian's more of a 5 star at this machine. I was a 0 star until a week ago. I've been using it for a week. I'm gonna spend about 2 or 3 months on it so I can really get the lay of the land, and I'm good at seeing what holes look like and how they are supposed to perform. And I know all the rest processed in the shop. So I wanna make sure that the holes that we're turning out are actually really exactly correct. So I plan on just camping here for 2-3 months. So what I'm gonna do, these nozzles started as a blank, and Brian then EDM'd them for me. He burns them, and we put what size wire we're gonna use, how many holes, what the spray angle is. Example, 155 degree spray angle, hole count 5, 10.5 thou piece of wire, elliptical pattern, yes. So basically this is our eco nozzle. Eco doesn't necessarily mean cheap, but it's more designed for the economy driver. It's smaller than the P570, which is a really, really common part. And that P570 was something that we used for years. Factory Bosch part that flowed 53 to maybe 55 liters of air per minute. And if we did things correctly, we got them to where they didn't really smoke, didn't run too bad, made good power. But as technology's gotten better, we have demanded more. Guys that are driving 12 valves want their 12 valves to act like common rails, and so do we. So throughout the years, even though we didn't tell you about all the changes we were making, we've been making changes. Now, you're gonna see on this screen that I've got media pressure, then we've got flow rate coming in, and it knows that it's at 41 liters a minute and it's on the climb, and it's gonna get to 50. Now, with these recipes, when you're creating a new recipe, that number isn't necessarily true. So because of that, when you create a recipe, you spend a lot of time editing and tweaking that recipe, trying to get your cut rate correct, trying to make sure that if we're asking for 50 liters per minute, we get 50 liters per minute. Now, the folks at Extrude Hone, when we told them that we wanted our software in liters per minute, they didn't really agree with us at first, but then I sent them several samples of nozzles labeled what size they were, and I sent them one of the AccuCals so they could set it up in their shop, and they were able to use all of the nozzles that I sent them as base test parts. And then they were able to create software that read in liters per minute. And we were able to maintain all of our 20 some odd year old recipes. Now, if they would have demanded that I needed to change from liters per minute to something else, that would have changed our game here, and that would have been difficult. So I was really thankful that they spent the time engineering and letting us maintain with what we already knew. So as you can tell, this is a pretty fast process. I'm not having to flow check these parts, every single one. On the Extrude Hone, we would use the Gilmont 4, 5, 6 times per nozzle. So it's a lot more time consuming. And with the silly putty kind of media, it has a tendency to grab atmosphere dirt, and then when you try and process that through a nozzle hole, it plugs that nozzle hole, and then that nozzle spray orifice doesn't see any media whatsoever, and that makes the other spray orifices grow way too big. So because of those things, stepping up and doing something a little bit different was kind of a necessity. And the other thing is as we've got some Australian customers that run them little Toyota Hiluxes, and their spray orifices were ridiculously small, like sub 5/1000 of an inch. So we had media developed, and it was still very, very painful to extrude hone those nozzles. Like, we would spend an hour per nozzle, and I wasn't really ever happy with the product. It was better than anything they'd ever had, but it wasn't like amazing. So when we got into this stuff, there is a learning curve, and it is pretty cool, but it's a bit of a challenge for a while. And I can't say that this was like right out of the box awesome either. But, you know, leaving Adrian on it for the last 2.5 years was probably the best tactic, because he got to really know the machine, understood how to program it very, very well. And, you know, I have 2.5 years worth of knowledge 30 feet from me now. So when I run into a problem or a bump in the road, then he can walk over here and show me what I'm doing wrong, and try to make me not feel real stupid, because I am his boss, but he's a lot smarter than me, so just being real. Now what I'm doing right here is, we used to go through brake clean, and we would try to get all these nozzles clean from the extrude hone media, the gloves, the glasses, to, you know, basically prevent any injury to me today in my eye, or long-term injury as the years go on from consuming this stuff into my skin. And this stuff that I'm using is simply just mineral spirits. So we pump the mineral spirits through these nozzles for a few minutes, and it knocks all that garbage clean. Then I can use just a can of compressed air to make sure that I've got all my sediment and trash out of there. When this thing runs out, I just recharge over there. So in a minute, I'm going to show you what the flow rate looks like on the AccuCal. So now that I've got 8 nozzles done, probably took me less than 15 minutes even when I'm talking, they're clean. I'm gonna take the camera away from the screen and I'm gonna move that camera and we're gonna show you the AccuCal, just so I can show you how repeatable the performance of this machine has given us. So we'll cut right now and change that. So the bottom of that ball is floating right at that 50 line. Nozzle number 1. Nozzle number 2. That ball's made out of glass, so we try to not bounce it off the top and then break free with little glass shards, get stuck in the tube. Over the years, we've learned how to use them correctly, and there's another 50. Now, if we look at any of the OEM parts that I've seen, you're never going to see them this consistent. So even though we can't turn out 5,000 parts a day, we can do really, really, really accurate parts. And I'm more proud of turning out accurate parts than I would be of turning out a lot of parts. So when you're getting our stuff, you're getting stuff that we know is going to be exactly the size that you need to do exactly what it was we're telling you to do. Whether that's a power goal or a mileage goal, anything like that, we're trying to make sure that you get the exact thing that you're looking for every single time. It's our 7th one and it's 50 as well. As well. So just for giggles, we're going to take a few pictures. We're going to post them behind me for some B-roll so you can see what AFM extrude hone and what just EDM looks like. Generally speaking, so these parts were 43 liters of air per minute and they're currently 50. So without changing any of the diameter of the hole, 43 times 120% would be 51. So I basically just changed this 43 times 118%. I just changed this 18% without change. The flow rate was changed by 18% without increasing any hole diameter. And why that's cool is because we create a velocity stack on the inside. So when the needle valve is in and at full closure, there's nothing. When the needle valve goes to lift, at that point, we have fluid that is seeing kind of a velocity stack. And that velocity stack really enhances the pressure leaving the nozzle. So the atomization is much, much better. Droplet size is smaller. Like I say, this hole is actually smaller than anything that any of the OEMs were using. But since we're able to employ, newer technology, we can get those really small holes to flow better than the bigger holes from 20 years ago. So not talking any trash about anybody, but as things maneuver, as things change, emissions keeps getting more and more stringent. All these new technologies, there's a lot of really smart people on this planet that are coming out with patents and creating technologies and machines and different ways to do things. So the old nasty dirty diesel doesn't have to stay nasty and old and dirty. At this point now we can run old trucks that make a lot more power than they did from the OEM, but that power is going to be a lot more efficient and a lot cleaner than it ever was way back in the old day. So I will go ahead and show you one of these on the inside on our bore scope of here. So let's go take a look at that. Sorry about that noise. So as you can see, just that little tiny polished edge right there is all we're after. Back in the old day, to get increases in flow, we would use extrude hone and we would blow those open to where those holes would almost touch. But that material is about 47 thousandths of 1 inch, and we really want the gun barrel or each one of those 5 barrels to be as long as possible so we can maintain our 155-degree spray angle, and we want that to penetrate into the pocket of the piston as deep as possible. So if we start blowing these holes open, we start to shorten up that 47 thousandths down to 40. down to 30, down, and then pretty soon you get a bunch of flow out of it, but it's not aiming in the right area anymore. So that's why we do what we're doing. Just real quick, just for giggles, we're gonna walk over and I'm gonna introduce you to Brian. He's on the EDM, and I'll just grab some of his wire stuff that he's got there so I can show you a little bit of what that's like. Brian.
Yes, sir.
Can you get me the bin with the 10 thou wire in it?
Yes, I can.
Thank you, sir. Okay, so basically we've got 094, we've got 10, I've got 7 1/4, I've got 865, I've got 7/4. We got all sorts of different wire options in here, and this stuff comes every 10,000ths of an inch. So depending on the recipe, I got 7/7, I got 9/4, I got all sorts of stuff in here. We got 8/4. Now this stuff's ground within 50 millionths of 1 inch. So it's a piece of tungsten that they then grind, chop up into length, and then we order these sticks. They go into the EDM. Thank you, sir. Brian, what are you cutting right now? What hole diameter? What wire diameter do you got?
11.5 thou.
11.5 thou. Can I see one of yours that you've already cut?
Sure.
So he's got 11.5 thou piece of wire. The wire doesn't necessarily touch the nozzle or do any of the cutting. So, the water that's in the machine is actually kind of what's burning its way through there, and the tungsten is charging that water. So what I'm gonna do is change that, maybe there. Drop this, drop this, drop that. So I have, you got 11.5 thou wire, Brian?
Yep.
And our hole diameter is 13/4. So we've got red lines on that. I just laid those dots. So we've got 13 thousandths 4/10 is our hole diameter. Now there's a little bit of, I mean, I can see it because I know what I'm looking at, but there's actually like kind of a burst of steel just around there. So as soon as we run a little bit of AFM through that hole, it's going to deburr that and clean all that stuff up. And that hole is probably going to come out to be about 13 thou, not 13/4. But as far as roundness is concerned, we got a decimal point. We got, what is that?
4 zeros?
We got 1, 2, 3 zeros and then a 5. So how many thou? That's
5 10,000ths.
5 10,000ths, thank you. So 5 10,000ths of 1 inch out of round is what that hole shows right now. But again, if I was to run a little bit of extrude hone or AFM through this, that would actually, that 5 10,000ths would decrease and it'd probably be a 2 or a 3. So pretty much as accurate as you can get. Now, real quick, I'll show you kind of a side profile. There we go. So right here, see if I can focus on that really, really well. There we go. Tyler, can you see the rust that's just inside of that right there?
Yep.
So we're using like a high carbon steel, and we can see a side profile where the wire goes through there and it leaves a little bit of surface finish there. This is really nice. It's really high quality EDM work, but the water that we've used is already starting to make little mineral deposits right there. So as soon as these nozzles get done off the, oops, sorry buddy. As soon as these nozzles get done off the EDM, they're gonna come to my bench on the AFM, and then between WD-40 and mineral spirits, I'm gonna inhibit and stop all this rust, and I'll be able to knock all that rust out of there very, very quickly. But since we've already seen what the outside looks like, let's go look and see what the inside of just EDM looks like. So EDM only. We've got a real sharp 90-degree edge. Our EDM is CNC, so we don't have any of the overburn. A lot of the other guys would come in this hole, they would come across and they would tag up in this area, and that tag mark's always where they cross and they crack actually. But since we're CNC, we go exactly as deep as we need to go every single time, and the machine automatically pulls back out. But you know, ultra high quality EDM work. Flow rate of this is going to be very, very accurate because those holes are going to be within like 50 millionths of 1 inch of one another. So it's a really nice machine. Definitely separates us from the others, I'd say. But now, just for giggles, I'll show you this antique. This thing was actually used for cleaning up nozzles back in the old days when guys would have to recondition parts. But we like to do it because I can mark where all those are coming in at, and then I can measure spray angle if I need to. But we're also looking to see what the atomization and the spray pattern looks like, and you can see that that is impacting that direct. Now if I run some AFM through this nozzle, it's going to be a lot more just atomized, and we're not going to punch that bowl near as hard. So just another cool little tool, probably built in the 60s, but here we are still using it in 2023 when Build Back Better is the new thing. So there you have it. Check you later.